Hi everybody, in today's video we're going to be looking at the paper 2H from June 2019 Edexcel GCSE Maths. Let's get started. So as we look through this calculator paper, we start off with an inequality, so we're going to subtract 11n from both sides to get 3n is greater than 6, so n is greater than 2. On the number line below, we're going to do these sets of values, so we're going to subtract 3 from all of these to get negative 5 is less than x, less than or equal to 1. So we're going to do an open circle on 5 and a closed circle on 1, and we're going to connect those together with a line there like that, some arrows pointing in. Question 2, we've got a grid here, so we're going to use our calculator function with the menu and go down to table, and we want 2x minus 3. Check out my calculator video if you're not sure about this function. We're going to start at negative 2 and finish at 4. And we get negative 2 is negative 7. So we can plot these now. Negative 2, negative 7, negative 1, negative 5. And we go through like that. 0 minus 3, 1 minus 1. And 2, 1, 3, 3 and 4, 5. And in an exam you would draw those together with a straight line and pencil and a ruler. Hannah is planning a day trip. This is a sample, stratified sample here. So out of the 195 students, how many do you think will go to the theme park? So we've got 10 students out of the 30 in the sample, so that's a third. So we're going to do 195 times 10 over 30, or divided by 3, and we get 63. State any assumption you made and explain how this may affect your answer. So we're assuming that this is a random sample, because if it isn't, then that would affect the numbers within these different categories, and this would change the number of students for each one. Okay? So we want this representative of our sample and having it in the right proportions for each one. Cuboid that's 2/3 full of water. So let's work out the volume of this. The volume is going to be 30 times 6 times 19, like that. So 30 times 6 times 19, and that gives us 3420. 3420 centimeters cubed. Container is 2/3 full of water, so we're going to times that by 2/3, and that's 2280. This is 2280 centimeters cubed full of water, so let's just say it's going across there like that. And we want to fill the cups. So centimeters cubed into liters, so we're going to do 1000 centimeters cubed is 1 liter. So we're going to divide by 1000, we get 2.28 liters, and we're going to divide that by 275 to give us the number of cups. So we're going to do 2.28 liters, we're going to change that into millimeters actually, 2280 divided by 275. So that gives us 8.29. So the greatest number of cups is going to be 8. Question 5, we're going to do some trigonometry to calculate the length of AB, which is the opposite. We're given the hypotenuse, so we're going to be using sine 38 is equal to O divided by H, which we know. So O is going to be 16 lots of sine 38. So 16 sine 38, which equals 9.85 to 2 decimal places. Sally used a calculator to work out the value of a number y. The answer was 8.3. Calculate the error interval. So we're going to have 8.3 is the smallest that we can have, and that's going to go up to 8.4 there. £360 is shared between 4 people. Abby to Ben is going to be 2 to 7, and Chloe and Dinesh get 1.5 times the amount Abby gets. So Chloe and Dinesh are going to get 1.5 times Abby's. So 2 times 1.5 is 3, so they're both going to get 3. And we now have, when we add these up, we're going to get 15 shares. So we're going to share 360 into 15 pieces, and that gives us 24. So each share is worth £24. And who do we have to work out? Ben. So Ben is 7 there. So 7 times £24 is 168. So he gets £168 there. Write this in standard form, so we need to put our decimal place there to get it in between 1 and 10, so 5.62. And we're going smaller, so we're going to have a negative here, 1, 2, 3 spaces. 1.452 times 10 to the 3, we're going to move it 3 spaces to the right. That's going to give us 1452. Check out my calculator video where we do standard form on the calculator for us. Okay, the circumference of circle B is 90% of the circumference of circle A. So we've got an A to B here. Let's make A 1. Then B is going to be 90% of that, so 0.9. Find a ratio of the circle, area of circle A to the area of circle B. So this is a length scale factor because it's the circumference. So the area of A to area B is going to be the square of this. So 1 squared and 0.9 squared is 0.81. Okay? So the ratio of the area of the circle is 1 to 0.81 or 100 to 81, like that. Square E has length E and F has length F. The area of square E is 44% greater. Okay, so we have two squares, E and F. Actually, it's the other way around. E is bigger. So E and F. And the area of this is 44% greater. So if this is 100% and this is 144%, then when we divide those, we get 1.44 as the area scale factor. The area scale factor is 1.44 times. So if we square root that 1.44, that gives us the length scale factor. Okay, so the square root of 1.44 is going to be 1.2. Yep, so the length scale factor is 1.2. So E is 1.2 times bigger than F. And if we want to get rid of the decimals, then we can times by 5 and we get a 6 to 5 there for the length. Probability, so we know we're going to try and add these up to get 1, and on any day is 0.15, so all of these are the same. Okay, so some easy 2 marks there. Work out the probability that her train will be late on at least one of these 2 days. So you can go late, not late, you can go not late, late, or you can go late, late. So there's quite a few possibilities there. Or if we're a little bit more savvy with this, we can do 1 minus the probability of being not late twice. Okay, so that cuts down on the amount of work that we have to do. So 0.85 times 0.85, like that. So 0.85 squared, and we're going to do 1 minus that. So 0.2775, 0.2775 is a probability. Cumulative frequency, so we just have to add these up. 5, 35, 55. Add a 15, that gives us 70, 78, and then 80. Okay, just check that it gives you what's in the question at the top. That's always there. And then we have to plot this, so we always plot the end point of the class. So that's going up in 20s. So we've got 5, 35, and 55. 5, 35, and 55. And then 70, 78, and 80, like that. And you would try and connect these with a smooth curve, which is pretty difficult on computer, something like that. And we're going to estimate the percentage of the office workers who take more than 90. So you're going to read off your 90 minutes, and that would be around about 74 on mine. So 74 or less would be less than 90 minutes, so we have to go from 80 to 74. So we've got a difference of 6 there. Okay, so we've got 6 people that are longer than 90 minutes out of 80. So we're going to work that out as a percentage, and we get 6 over 80, 80 times 100, 7.5. Sector of a circle, so we know the formula for a sector is pi r squared, and we multiply that by the angle, which is there, over 360. Okay, so in this case we don't know what theta is, but we do know that the area is 40 centimeters squared, so we can rearrange this and we get 40 equals pi lots of 7 squared times theta over 360, times both sides by 360, so 360 times 40, that gives us 14,400 equals 49 pi times theta. So theta is 14400 over 49 pi. So that's not going to be a very nice number, but we'll store that in our memory. So we'll divide that by 49 pi. And that goes into the memory slot A. So I put that in slot A. Calculate the perimeter. So the perimeter of the sector is going to be the 2 radii. So we've got a 7 and a 7 there, and then we need the arc length. So we're going to do 2 pi r, which is the full circumference, multiplied by theta over 360. We've stored theta in our memory, so we've got 7 plus 7 plus the arc length, so 14 plus 2 times pi times 7 times theta over 360, and that will give us, so there's our theta divided by 360 times 14 pi, and then plus 14. So we get 25.4 centimeters to 3 SF. Algebraic fractions, let's do the brackets first. So we have, on this fraction here, we've got x plus, what do we want, 5 and x minus 2. And the clue is kind of here because we're doing a division there. So we have that over x minus 1. And we're doing x plus 5 divided by this whole thing. So when you're dividing by a fraction, we're going to flip the second one and make it a times. So we're going to have x minus 1 over x plus 5, x minus 2. And you can see that now we have this on the top of the fraction. So this would be x plus 5 times x minus 1. So I'm just going to put that there. That's the same thing. And we can now cancel. So we have x minus 1 over x minus 2. And we have the 6 plus that whole thing. Okay? We need it as a single fraction. So we need to turn this 6 into a common denominator with x minus 2 on the bottom. So we have to times the top by x minus 2. Okay? And then when we have this common denominator, we can now add these. So we've got 6x minus 2 plus x minus 1 all over x minus 2. 6x plus x is 7x. 6 times negative 2 is negative 12. And then we're going to minus 1 is negative 13 over x minus 2. Okay, speed, time, graph. Calculate an estimate for the gradient at t equals 15. So t equals 15 is there. And we would draw our tangent at that point. So we would try and get the tangent going something like that. And then we would make another triangle here and try to read off the points to work out the gradient. So Let's try and see how much the rise is. We're going from 15 to 20, so we've got a rise of 5. And going across the bottom, each of these squares is, so 2 squares is for 1, so we're going 2.5, 3, 4, 5, 6, 7 there. Okay, so the gradient is going to be 5 over 7. Describe what your answer in part 1 represents. So when you do the gradient of a speed time graph, the gradient gives you the acceleration. Okay, and we can link that to our differentiation, because if you differentiate a speed like a velocity, you get the acceleration because you're working at the gradient of a tangent at that point. Work out an estimate for the distance the car travels in the first 20 seconds. Use 4 strips of equal width. So if we're going from 0 to 20 seconds and we need 4 strips, then we need to split that into 5-second intervals, and we're working out the area under this graph. But because it's a curve for GCSE, we haven't done any calculus to help us along with this, so we're going to estimate this by using trapezium. Okay, so that each of the trapezia are a width of 5, and we're going to take these points and read them off and try and work out an estimate for this. So if you imagine a trapezium is just going like that, then it's slightly overestimating in this case. So the first one is going to be half the 2 parallel sides, so 0 plus, what's that, about 4, and times by the width. And the second one is going to be half, this time we're going from 4 plus 11, 12, times 5. The third strip, so we're going to add all these together at the end, we're going from a half of 12 to 15, 16, 17, 18, times 5, and the very final strip is a half of 18 plus 20. Okay, so I'm just reading off these values here to try and get my heights of my trapezium here. So if we start adding this together, starting from the top, we've got half of 4 times 5, that's 10, plus 4 plus 12, 16, 8, 40. Then we've got 30 over 2 is 15 times 5 is 75. And then 38 over 2 is 19, 5 is 95. So we've got 95, that's 170, 180, 220 meters as our estimate. Question 15, we're going to make m the subject. So we're going to multiply through the denominator to get rid of that. And you'll notice we've got an m on both sides, so we need to expand this whole thing, collect the m on one side, so it doesn't matter which way round, but we'll choose the left, so we'll do fm minus 3m, and I'm going to take the negative f over the other side to get 4 plus f, or f plus 4, it doesn't matter. Factor the m, and then we're going to divide through by that bracket to make m the subject. So 4 plus f over f minus 3. There'll be a couple of alternatives there depending on which side you put the m. Straight line has an equation like that. We need it in the form of y equals mx plus c, and at the moment it's 3y, so we're going to divide through by 3 to get y equals 4/3 x plus 7 over 3. And we now know the gradient of this line, so the gradient is 4 over 3. The equation of the straight line is perpendicular to that, so we need the perpendicular gradient, so 4/3 times the perpendicular gradient is equal to -1. They always multiply to give -1, so the perpendicular gradient is -1 over 4/3, or -3 over 4. You can put that in your calculator. And so our perpendicular line is going to be y equals -3/4 x plus c. Okay, so if I do a quick sketch for you here, 4/3 x plus 7/3 is something like that. We're looking for the perpendicular line, but we don't know where it goes. through. That's why we need this point 3 minus 5, so somewhere down here to anchor this in. So we're going to substitute for x and y here. When y is negative 5, then x is going to be positive 3, and that allows us to find our new y-intercept. So minus 5 equals minus 9 over 4 plus c, and we're going to add minus 5 plus 9 quarters to get our c value. So 9 over 4, let's do minus 20 over 4 plus 9 over 4, and so we get that's minus 11 over 4. So our new equation is going to be y equals minus 3 quarters x minus 11 over 4. So we've got some cubes in a bag, red and yellow, large and small. Some are in the ratio of 4 to 7, the others are in the ratio of 3 to 5. Explain why the least possible number is 88. So if we divide it into 11, so the number of cubes that we have has got to have a factor of 11, and 3 to 5 is going to be 8. Okay, so the least that they could be is the lowest common multiple of 11 and 8, which is 88. So you can put that into words there. All the small cubes are yellow. Okay, so what we need is a table here like this, and we'll have red and yellow and small and large, and these total 88, or at least they'll be in that ratio. So let's see if we can piece together some of these. This is the total column and row here. So small to large is in the ratio of 4 to 7. So we need to divide 88 by the total of 4 and 7, which is 11. So that's going to be 11s into 88 go 8. So 8 times 4 is 32. 8 times 7 is 56. If we look at the ratio of red to yellow, that's 3 to 5, so that's going to be a total of 8. So each share is 11, so we've got 33 to 55. And then we need a bit more information to get this started, so that's why it says all of the small cubes are yellow. So all of the small cubes are yellow. That means we can start to now fill in the rows and the columns like this. So the one that's missing, that would be a 23 there. Just check that works both ways. Okay, so work out the least possible number of large yellows. That's going to be 23. Circle theorems. We have an isosceles triangle here, so let's just quickly put these in. 140 split in half is going to be 70 and 70, like that. And then we have a cyclic quadrilateral there. So the A and the C in this cyclic quadrilateral ABCD, they're going to equal 180. So 70, that needs 110 to make 180 there. Another isosceles triangle here, so these angles are the same, and they add up to 180. So 110, that leaves 70. So this is going to be 35, and this is going to be 35. And then we have 105 in total here. So we need 75 in there, and that's angles on a straight line. That's your angle ADE. Triangular prism, DM to MA. So M is on the point there where it's 2 to 3 ratio. So it's 2/5 when we add those up. 2/5 of the distance. So a fifth of 15 would be 3, so 2/5 is 6. That leaves 9 there. That's in a 2 to 3 ratio. And we need to go between E, M. So there's the point M. We're going to go up through there, come down to B, and then go across there and find the angle it makes with the plane. So we can use this first triangle here, AEB, and find the EB, and that is the opposite, and we have the adjacent. So we're going to do tan 35 is equal to O over 15. So EB, which is the opposite, is going to be 15 tan 35. We can then create our second triangle here, but we need to know the length MB. So now we have a triangle that's going from M to B and then up to E. We want to know, we know EB, we want theta, we just now need to find out what MB is. So we've actually got another triangle here, 15 and 15, sorry, not 15, that's going to be 9 and 15 there. So M to A, sorry, M to A to B, and we want to find MB. So we're going to do Pythagoras on this. Square root of 9 squared plus 15 squared, that's going to be our MB. So 9 squared plus 15 squared is 306. So MB is root 306 and EB is 15 tan 35. So to find out theta, we've got the opposite and the adjacent again. So we're going to do tan theta is equal to EB over root 306. So 15 tan 35, that's going to be EB, and we're going to divide that by root 306. So that's tan theta. So theta is going to be the inverse tan of that number there to get 30.98. What do we need? One decimal place. That's actually 31.0 degrees. Okay, last question here. We've got some vectors. What do we have here? CD, that's A. D to E is B. And M is the midpoint. So we've got a half B here and another half B there. And that's going in that direction. F to C is A minus B. And we need to find F to E. Okay, so F to E, that shouldn't be too bad because we can go F to C across there, plus C to D, plus D to E. F to C, that was A minus B. C to D is A, and D to E is B. So A minus B plus A plus B is just 2A. X is the point on FM such that F to X is N to 1. CXE is a straight line. So there's a straight line going all the way through there. So when we have a straight line, we want to take the whole line and a vector that's contained within the line. So we could go C to X, or we could go X to E. Okay, so let's do C to E first. C to E is A plus B. And another vector contained within that straight line could be C to X or X to E. I think, well, both of those are tricky, so we're going to need FM to help us out as well. So let's work out FM. That's going to be A minus B plus A. So we're going up across. B over 2 would get us to M. So FM is going to be A plus A is 2A minus B plus B over 2 is minus B over 2. So that's going to get us from F to M. And to go from X to M is, well, if this was like 6 to 1, for example, then this would be 1/7 because we add those up. Okay, but here we've got algebra, so this is going to be 1 out of n plus 1. Okay, so 1 out of the total. And that's going to be 1 over n plus 1, the distance of F to M. So the whole distance is that, and we want a fraction of that. So we're going to do 1 over n plus 1 brackets 2a minus b over 2. So that is our x to m. And then to go from x to e, we're going to have to do xm plus me. So we're going to have 1 over n plus 1 brackets 2a minus b over 2. That's our xm. And we're going to add b over 2 to that to get to e. Right, let's see if we can collect this up a little bit. So we've got 1 over n plus 1 multiplied by 2a, so I'm going to put the 2a on the top, minus this thing in front multiplied by b over 2. So we're going to have b over 2 brackets n plus 1. And then we're going to add b over 2 at the end. And we can take the a out as a factor here. So we've got 2 over n plus 1. And then we're going to have b over 2. We've got b over 2 as a factor here. Let's just take out b. Actually, let's collect these together. We'll collect them together actually. So we're going to have minus b over 2 brackets n plus 1. And I'm going to make this a common denominator by multiplying top and bottom by n plus 1. Like that. Okay. So I'm going to just take this up here. And we're going to have a over 2 brackets n plus 1. Then we're going to have negative b over 2n plus 1 plus bn plus b over 2 brackets n plus 1. So we can collect these two together and we get the negative b plus b. That's going to actually cancel that out and we're just left with bn over 2 brackets n plus 1. We have a brackets 2 over n plus 1. And that's going to be a plus there. Okay, so hopefully you can see that that one has cancelled with this, and that's all disappeared. And we'll take the b out as a factor for the second one. We've got 2 over n plus 1 plus b brackets n over 2 n plus 1. Okay, so it's complicated, but what we've done now is we've expressed x to e as a single vector there. It looks horrible, but that's what it is. So we're just going to remove some of this from here. So we have the ratios of a's to b's for CE. That is a over b because they're in a one-to-one relationship. And then for the x to e, we have this weird 2 over n plus 1 divided by the b brackets n over 2 brackets n plus 1. You can see that we're trying to cancel these down so that we can eliminate these and try to generate an equation. So we've got an a on both sides of these equal signs, so we're going to divide both sides by a and cancel those. We're going to get rid of the b's to do that. And we can now cross multiply this, so we've got n over 2 brackets n plus 1 is equal to 2 over n plus 1, like that. We can then cross multiply again, so we're going to have n equals 2 brackets 2 lots of n plus 1 all over n plus 1. So we can cancel this, and we're left with n equals 2 lots of 2. So after all of that, this is in a 4-to-1 ratio, so n is equal to 4. Wow, so that was a really tricky finish to that paper, but hopefully you can see the concept there. If you're trying to prove that something's on a straight line, you get the ratios of the vectors, put them equal to each other, and then you can see they're in a 1-to-1 or a 2-to-2 or 2-to-3, whatever it is. In this case, we got a strange relationship of 4-to-1, but you know that worked out quite well. And the paper was very, very tricky at times. So if you have any questions about any of this, then do get in touch, Mr. Wakeling at bowtieteacher.com, or put something in the comments below and I'll do my best to support you. Thank you very much.